We're going to finish up our Chapter 11 notes today. So you should be on page 13, and the title of this one is Finding the Intersection of Two Trig Graphs. Well, what's going to happen on these two examples is we're going to be sketching on the same set of axes. Whoops. We're going to be sketching on the same set of axes two different graphs. And what I've given you on this example is a y equals 2 cosine of x. So we'll just figure out probably in our mind what that might look like, 2 cosine of x. And then we're going to sketch y equals a half a sine of x on the same graph. And we're going to graph this only between 0 and 2 pi. This is from x is equal to 0 to 2 pi. And then after we get done graphing them, we're going to determine the number of values of x. That means, are there 2 values? Are there 4 values? Just how many values of x between 0 and 2 pi satisfy the equation that those two trig functions are actually equal to each other. So what it means is, when we graph this, and then this on top of it, they'll probably cross over each other once, twice, maybe 3, 4 times. And however many times they cross over each other, those x values will be the x values that would satisfy this equation. And we're just going to determine how many of the values of x would actually satisfy this equation, which is going to be a little bit different than the second example down below. So let's get started on this. We're going to start graphing y equals 2 cosine of x. So on 2 cosine of x, the amplitude is what we look for first. It's 2. The number in front of the x is the b value, which is the frequency, is equal to 1. And the frequency means there is going to be one full cycle of a cosine curve between 0 and 2 pi. That's what the frequency means. One cycle of the cosine between 0 and 2 pi, which is where we're being asked to graph this graph. And that's about all we need to know to graph 2 cosine of x. So we've got these set of axes here, and let's put 2 pi all the way out to the right because that's what they want us to do. They want us to end at 2 pi. Make sure you're always aware of where they want you to graph. And then we're going to divide this exactly in half like we did before. So halfway between 0 and 2 pi is 1 pi. And halfway between 0 and pi is pi over 2. And then halfway between these two is 3 pi over 2. And then on our y-axis, we have to go up to 2 because that's the amplitude. And a cosine curve starts at the max, which is the amplitude, max, 0, min, 0, max. Try to get this as good as I can. I'm not the best artist, but I try. Here we go. And make sure you label this because we're going to put the other trig graph on top of it. So label this one, y is equal to 2 cosine of x. The other graph, I think I might do that in a different color just to make it pretty. We're going to graph y equals sine of a half x. So the sine of a half x has the amplitude that's equal to 1. And it has the frequency. Remember, the number in front of the b is the frequency. The frequency is equal to 1/2. And if you wanted to calculate the period of this graph, period is 2 pi over a half, which would be 4 pi. So if we actually wanted to graph a full sine cycle of this, we'd have to go all the way out to 4 pi on our x-axis to get the whole 5 points. But we're only going to be graphing a half of a cycle. So what does a half of a cycle look like? Well, a full cycle of a sine curve goes 0, max, 0, min, 0. So there's our full cycle. And if we only wanted to do half of it, we're going to forget about this second half and just do 0, max, 0. And that will be it. And this point over here is going to be this 2 pi point over here. So we're going to start here at 0. 0 means 0, 0. We're going to actually end at 0. That's where we end at 2 pi, way over here at 2 pi. And then halfway between the 0 and the 2 pi, which would be 1 pi, we're going to hit the maximum point, which is 1. The amplitude on this is just 1. So this is just going to be a very, very stretched out sine curve, and it's very low too because the amplitude is only 1. So it's just like a little bump on this, and we'll label this y is equal to the sine of 1/2 x. And the question is asked, how many values between 0 and 2 pi will satisfy the equation? Well, the number of values are the number of times where it crosses each other. So it crosses each other here. It crosses each other here. So 1, 2, there are 2 intersections of these 2 graphs. So the answer to the question is 2, because there's 2 intersections. 2 values of x satisfy 2 cosine of x is equal to sine of 1/2 x, or satisfy the equation. 2 values of x because of the 2 intersection points. It doesn't say what they are, it just says how many values are there. And that's the difference between the top graph and the bottom graph. The bottom graph says we're going to be graphing now something different, y equals cosine of 1/2 x. And then we're going to be graphing y equals sine of -x. So we're going to be graphing those two functions on this set of axes, and again they want us to go between 0 and 2 pi. The difference in the question asked on this one, it says solve the equation for all values of x. So we're going to have to answer the question, x is equal to what? Question mark. And those x values where they cross over each other, they're going to be the answer to this problem. So let's get going on this one. Let's graph y equals cosine of 1/2 x first. So this function right here has an amplitude that's equal to 1. It has a frequency that's equal to 1/2. So that means we're going to get 1/2 of a cycle between 0 and 2 pi. Well, what's 1/2 of a cosine cycle look like? Well, a cosine cycle is max, 0, min, 0, max. So there's your full cosine curve. If we only want to get 1/2 of a cycle, we'll cut off this half, and we're just going to go max, 0, min. And this point right here will be the rightmost point, which is 2 pi. Remember, we get 1/2 of a cycle between 0. This point right here is going to be 0, and this will be 2 pi. So halfway between 0 and 2 pi is going to be 1 pi. So we're going to get a graph that looks like this, max, 0, min. So let's set up our axes again. Let's go all the way out to 2 pi and cut it in half, call it pi, cut it in half. That's pi over 2, and cut that in half and call it 3 pi over 2. The amplitude on both of our curves is 1, so I think I'll put a 1 up here a little bit higher than I did before because we had an amplitude of 2 on the other one. So here's our amplitude. So our cosine curve goes max, 0, min. We've got a little bump going up here. It's not a straight line over, but it's a little concave down. And then we've got a little concave up coming here to touch that. And that is our y is equal to cosine of 1/2 x. So there's our first graph. The second graph is y equals negative sine of x. Well, the amplitude is still 1. The frequency is 1. So we're going to get an entire sine curve here. The only difference here, it's going to be upside down because this a value is negative. The amplitude is 1, but a is negative. So an upside down sine curve, instead of going 0 max, 0 min 0, it's going to go 0 min 0 max 0. That's what makes it upside down. So it's going to look like this. Sometimes it's best to get a little freehand sketch off to the side before you put it on the XY axis. So 0, we're starting at the origin, 0, 0, 0, min 0, max 0. And whenever you get questions like this one where it says solve the equation for x, it's going to be very, very clear what the x value is. They're going to cross over at a specific point like pi or pi over 2. You'll never get something like this. This is kind of ambiguous where they cross over with each other, but this one it's very clear. So the answer to this question is x is equal to pi, right? This is the x value. X is equal to pi satisfies the equation cosine of 1/2 x is equal to negative sine of x. And you can test that theory out if you want to. If you wanted to put x equals pi in here for x, the cosine of 1/2 pi is the cosine of pi over 2. Well, the cosine of pi over 2 is actually 0. And the sine of pi is actually equal to 0 too. So this makes this a true statement if we actually went in and checked our answer. And then the last thing you can do is you can pull out your graphing calculator and make sure that your graphs are right. Like on this first one, example number 1, if you wanted to put in y1 2 cosine of x, and in y2 you can put sine of 1/2 x. Instead of doing a zoom trig, which we usually do, this value over here, this x min, is 0. They want you to go between 0 and 2 pi. So that's how I change my x max and min to match up where they want me to graph. And so then we can see that here's our first cosine curve that we graphed here. And then here comes 1/2 of a sine cycle around here. And those are the two values right here where they cross over each other. And then the other example was cosine of 1/2 x and negative sine of x. Got that right, yeah. And the window is still the same between 0 and pi over 2. So if we graph that, here comes our first, this is a cosine of 1/2 x. There's 1/2 of a cosine cycle. And here comes our upside down sine cycle. And this intersection point right here, if you wanted to, you could do second calc intersect. Second calc intersect. Enter, enter, enter. And it'll tell you x is equal to 3.14. You know that's equal to pi, hopefully. So that the calculator will actually help you out if you want to. So that's it for chapter 11, and I'll see you tomorrow. Have a good night.